My Physics 1 Lab 5 presentation. Introduction. Objective. The purpose of this lab is to analyze an experimental collision between two bodies and determine if the momentum is conserved and if the collision is inelastic or elastic. Principles. Conservation of momentum. If the force is equal to 0, momentum is conserved. However, if there are external forces acting on the system, such as friction or gravity, momentum will not be conserved. Generalized by the formula P final equals P initial. This principle will be important in our discussion section. Inelastic versus elastic collisions. If delta KE equals 0, then our collision is elastic. If delta KE does not equal 0, then our collision is inelastic. The only equation we need for this experiment is the momentum principle, which defines force as a change in P over the change in time. Thus, momentum is defined as mv, because if you divvy this up, it would be delta v over delta t times mass. This is important because if time is constant and there is some change in the force, then there must be a change in delta p, thus making our collision, thus violating the conservation of momentum. System and surroundings. We'll be analyzing collision as if it were only the blocks. All other forces will be external. Results. Momentum is not conserved, and the collision would be, or is, inelastic. Experiment. Initial conditions. The experiment will be consistent of two blocks. At the start of the experiment, one block is at rest and one is moving towards it, put in motion by an impulse. Our moving block is block 1, and thus its velocity from now on will be v1. Our initially stationary block is block 2, and thus its velocity from now on will be v2. Our blocks are only moving across the x-axis for the entirety of the experiment. I set mass as 1 kilogram because theoretically mass will not matter if both blocks are consistent and the same. This will be true if the mass of both blocks is consistent and the same, and the nature of the blocks are the same. This will be true because we are using two identical objects. This comes from the fact that if we set Pi equal to P final, we're going to have V1m plus V2m initial and initial equals V final m plus V final 2m, and the m's on both sides will cancel because they're in every part of the equation. Initial conditions continued. We have a small distance between the blocks at the start. My axis at the center of mass B2, and B1 is already in motion. Model prediction. Theoretically, we would predict that our momentum is conserved because ideally we are analyzing a closed system. There are no visible outside forces acting on the object. However, the table will exert a frictional force on the moving object. Thus, F external does not equal 0. Thus, we can expect a change in momentum. We will predict the change in KE does not equal 0 because there is a loss of energy in the system due to friction between the blocks during the collision. Here's my experiment. My tracker video. And now we're getting to our analysis. Model versus experiment momentum. For my analysis, I will be using t equals 0.068 seconds when block 2 is at rest, and t equals 1.367 seconds when block 1 is at rest. B1 is not. Whenever we started the analysis, I wasn't analyzing the block 2 because block 2 wasn't moving, so its velocity is obviously 0. And here, as you can see, we are going to have that momentum is not conserved because the velocities aren't equal to each other and mass does cancel. Model versus experiment, and elastic versus inelastic. I'll be using the same time intervals. And since, here it's also kind of obvious. If you have the same mass and the same kinetic energy on both sides, then mass cancels and they are the same. Or they're not the same, so it's not conserved. Or so our collision is inelastic. Discussion. Why was momentum not conserved? / what does it mean? Momentum was not conserved because there was an external force acting on the system, friction or drag, and thus our blocks were experiencing a net change in momentum. If there is a net change in momentum of the system, conservation momentum pulls apart because delta P does not equal 0. What would happen if a collision occurred in a vacuum? Momentum would be conserved in a vacuum. There's nothing to exert a normal force on the eraser. The external, oh my god, dude, thank you.